Okay, let's do a kind of fun, different example. We're going to take everything we've learned about f, f prime, and f double prime, and we're going to kind of put that all together into a challenging puzzle where the goal is to sketch a function. We want to specifically make a continuous function, f, that satisfies the following conditions. And so I've laid those conditions out into, and I've color-coded them with conditions about f, conditions about f prime, and conditions about f double prime. So, excuse me, what I'm going to do is I'm going to draw a graph over here. Okay, I'm going to draw it roughly, hereabouts. Okay, here's my x-axis and my y-axis. And I want to draw a graph that satisfies these conditions to the best of my ability. And as long as it satisfies these conditions, it's fine. And so there's going to be some sort of unknown information about exactly what the y-coordinates of certain points are. We don't really care about, and so we're just going to sort of make some stuff up as we go. But we're going to do it carefully. And so I'm going to go through the conditions and sort of analyzing f, f prime, f double prime, and do my best to fill in this graph along the way with whatever information I can get. So first, it tells me that f of negative 2 equals 0. Well, great. That means if I find negative 2 on my x-axis, let's put it here, okay, then at that point it equals 0. And then f of x is greater than or equal to 0 for all x in R. So it doesn't say anything else about any other zeros. I'm going to assume that that's my only 0, okay? There could potentially be other zeros, but it's never going to be negative. It says greater than or equal to 0 for all real numbers. So, all right. So next, f prime of negative 2 equals 0. All right, that means I'm going to have a horizontal tangent line at negative 2. So that point that I already graphed right here is going to be a horizontal tangent line. Possibly a maximum, possibly a minimum, possibly neither. Although if I take into consideration what I already know, that it's greater than or equal to 0, having a maximum is unlikely, right? Because it would have to be concave down there. Having a minimum is possible. Having neither, where either it keeps on going up or keeps on going down, is also unlikely because it can't go down, right? So I'm guessing that's going to be a minimum, but we'll see. So f prime of negative 2 is 0. Also, f prime of 0 is 0. So let's plot a point for 0. At 0, let's say it's somewhere up here. I'm going to plot it somewhere like there. And that is also going to be a point where I have a horizontal tangent line. So there we go. So now, I'm going to move on to my next thing. It says f prime of x is less than 0 if x is less than negative 2. So what that means is to the left of negative 2, it's decreasing. So if I'm coming all the way from negative infinity, if I'm coming in from the left, it's got to be coming down. I'm just going to sort of lightly pencil in what that's going to look like, coming down. I don't know the curvature yet, but I know it's decreasing to the left of negative 2, and it has to reach negative 2. It has to reach 0 at negative 2. And then the other thing it says is greater than or equal to 0 if x is greater than negative 2. So that means it's going to be increasing or possibly flat for every point on this side. So roughly increasing and then increasing more, maybe? All right, something like that. Next, now let's move on to the second derivative. So now this information is going to tell us about concavity. So the first thing it says is that f double prime of negative 1 equals 0. Ooh, interesting. Negative 1 is a number we don't know anything about yet, except that the derivative is positive at that number, right? So I need to just decide where I'm going to plot that point. It doesn't really matter where I plot it. Let's put it here. That'll probably be fine. So at that point, that is going to be where it equals 0, all right? So let's just bear that in mind. Maybe an inflection point. We'll make a note of that. Inflection point? Possibly. If it's a 0 second derivative, it could be. Also, we have that f double prime of 0 equals 0. So at x equals 0, we've got this point right here. That also may be an inflection point. We'll see. And now, that question will now be answered, actually, by the next two pieces of information, which is that the second derivative is positive for x less than negative 1. So we're going to be concave up less than negative 1, and also concave up to the right of 0. So it's going to be concave up over here. All right, I'm going to go ahead and draw something concave up at this point. Now that I know that it's concave up to the left of -1, we can pretty much draw in this exactly what we want. So it's going to be definitely a minimum, as we suspected, at -2. And then it's going to kind of continue being concave up, but like that. So that's my graph, and I'm going to lock that in with a black pen here. All right, I feel confident about that part now. So no more pencil. Okay, so that's my graph to the left of -1, and also it's supposed to be concave up to the right of 0. Now at 0, it's actually like a horizontal tangent, so I better start with that. But then it's concave up and increasing, so that's pretty easy to draw, something like that. So I've got a 0 tangent slope, then it's concave up and increasing like that. And now the very last piece of information tells me about what's happening between -1 and 0, which is that it's going to be a negative second derivative, concave down, and so I can fill that in now. Gotta approach my 0 tangent slope here at 0, and then I've got to match this positive slope here at -1, like that. And you can see the positive concavity here, the negative concavity here, and then the positive concavity here. And it turns out both of these points at -1 and 0 are indeed inflection points, because there were changes in concavity at those points. So that demonstrates like how to solve a problem like this. I will admit that I came up with this problem, so I knew what the graph was going to look like in the end, but that is not how I figured out how to draw it. So I just want you to know that like the process I went through will work even if you don't know what the graph is meant to look like. All right, you can figure it out by kind of going through like I did and determining ups and downs, and where is it, where are we going to plot the point? Is it going to be somewhere in between, or like where is it going to be concave up, concave down, all that. And if you go through in the order like I did, starting with F and then moving to F prime and then moving to F double prime, then that tends to work pretty well. But yeah, this is a fun type of problem. It really feels like doing a little puzzle. And you have a few of these on your homework, and I think probably your worksheet as well. So I hope you enjoy them.